Okay, so basically what is acceleration? We denote this triangle as change in. Okay,
Okay.
this is change in. Okay, so basically acceleration is change in velocity per unit time. Let's say a car is moving at a 5 meter per second speed. Okay, a car is moving with a 5 meter per second of speed. Now at the second, let's say at time equals to 0. At first the car is moving with the 5 meter per second speed. At the second, which is time equals to 1, the same car is now let's say is moving at 7 meter per second speed. And then at t equals to 2 seconds, the same car again wait the same car again moves at, let's say, 9 meter per second speed. Okay, so basically when the time was 0, the car was moving with a 5 meter per second speed. When the time was 1, the car was moving at a 7 meter per second speed. And when time was 2, this car is moving with a 9 meter per second speed. Can you see that the speed is changing every seconds? This car
Yeah.
is in, the speed is increasing every second, right? Can you tell me the difference, like what is the difference between the speed, like what is the increase value, like how much did we add with 5 meter per second?
Yeah.
No, let's what's the difference between these two speeds, like the differences of these speeds, can you tell me?
The difference is it would be 9 minus 5
7.
over 2, which would be 2 meters per second squared.
No, it's 7 minus 5, which is 2 meter per second, the difference. Okay,
Okay.
and then from the second car, from this car, the speed is also 2 meter per second. So we can see that after every seconds, the car is increased, the car speed is increased by 2 meter per second, the car's velocity is increased by 2 meter per second.
Okay.
So isn't it the change that at a certain second the speed was 7, and then at another second the speed was 5, and this is the change. So this is the change in speed, right? This is the change in speed, right?
Yeah.
And what was the definition of acceleration? It is the change in
Change in
velocity or
speed.
speed per unit time. And this time is how long, uh, for how long that this change occurred. Okay, let's say, so basically what will be the acceleration of this thing? The acceleration would be the change in speed, which is 2 meter per second. And for how long did the change occurred? For 1 second, right? 0 to 1, this is 1 second, right? The difference,
One.
the difference is 1 second, right?
Yeah.
So this is the time. So this is 2 meter per second divided by the time, which is 1 second. This gives me 2 meter per second squared. Did you get it?
Yeah, I get it.
Okay. Now let's say another car. Hmm, let me bring this car row from here to here. And let's say the car was at velocity equals to 0, velocity equals to 5 meter per second, velocity equals to let's say 10 meter per second. Okay, and at t equals to 0 and t equals to 3 and t equals to, let's say, uh 6. Okay, so basically there's a time interval of 3 seconds, right, between these two.
Yeah.
0 to
It's
3.
free. There's a three
uh,
second difference.
yeah, there are 3-second difference. So basically, what can I identify from this statement, that there is a 3 second difference, is that the car has been increasing its speed for 3 seconds, right?
Okay.
Okay. And what is the change in speed?
The
What is
change
the,
in speed, 5.
yeah, 5 seconds, right? From here to here. So the change in speed is 5
Yeah.
meter per second, right?
Yeah.
So what is the formula for acceleration? Acceleration is change in speed or velocity per unit time. And we know the change in speed is 5 meter per second and the time is 3 seconds, right? Right?
Yeah.
So what will this give me? What's the acceleration? Can you do the
5 of,
calculation for me?
5 of 3, which will be 1.6 recurrent.
1.67.
6 recurrent.
So this is my acceleration for this car, right?
Yeah.
And if I tell you the same thing to find between these two intervals, can you do that for me?
Okay. The difference between 10, the difference in speed will be 5. The
Exact
difference in
same.
time will be 3. It'll be the
Yeah,
same.
those are the same. So the acceleration would also be what? Same, right? So acceleration for that also will also be 1.67 meter per second square. So basically, what is acceleration? It is the rate of change of velocity. Okay.
Okay.
Anything divided by time is rate. Okay, you know that, right? Anything divided by time is rate. What is rate?
The one, the rate.
Yeah, anything that is divided by time, or like what happens in a particular time is called rate, right?
Okay. So anything in a particular time is called a rate.
Yeah. So basically, um, we can say that this change in velocity is divided by time. So anything divided by time is rate, right? So let's say rate is anything divided by time. Okay. And here the anything is the change in velocity, right?
Yeah.
So change in velocity divided by time would give me the rate of change of the rate of change of velocity.
Velocity.
Okay, cleared?
Yeah, clear.
Okay. Then let's say what is speed? Can you tell me?
Speed.
How fast
Speed.
or how slow we move from one position to another, right?
Okay.
So let's say the exact, let me get the exact, what, wait. Let me copy that and then what? Let's say this car is moving from position X. Let's say X, let me denote X with distance. Okay, X is distance, let's say. So let's say at first when t equals to 0, the car was at distance 0. And then when t equals to 6, the car was at distance 10. When
Okay.
t equals to 10, the car was at distance 20. Okay.
Okay.
Okay. So this is the distance of the car. Okay. X is distance. Okay. So now let's say I have to find the speed. So what is speed? Speed is again the distance divided by time. So it is basically a rate of change, rate of distance, right? We don't say that like that, but for your understanding, it's the rate of how much the car is traveling in a particular time. Okay, so basically their speed. Clear?
Yeah, clear.
So can you tell me how far this car has traveled for after 6 seconds?
After 6 seconds, uh, uh, it will be 10.
Yeah, it has traveled 10, let's say, meter.
Okay.
So it has traveled 10 meters. So we will write 10, and then for how much? How many seconds? It's 6. So basically 10 divided by 6, right?
Yeah.
This will give me exact 1.67. But this is meter per second. This is speed. Clear?
Yeah, that's clear.
Okay. Now let's say um, we have scalar and vector quantities, right?
Yeah.
So what is scalar and what is vector quantity?
That has only like one unit or like value, while a vector has like two. For example, speed
To
is a
what?
scalar quantity. Two
To what?
units. Like scalar has scalar speed is a scalar quantity because it's only considers like how fast you're going. Well, velocity is a vector as it considers how fast you're going and the direction you're going in.
It has direction. So basically, scalar has magnitude or value that has magnitude, and vector has magnitude and what direction.
Okay.
So just as you said that speed is a vector quantity, yeah, scalar quantity. So it's scalar speed because we don't know where the let's say a car is moving with 10 meter per second of speed. We don't know where, which direction. We just know that the car is moving with 10 meter per second of speed, right? But if I tell you that the car is moving with 10 meter per second speed with to the right, let's say, okay, the car is moving with 10 meter per second of speed to the right. That means it's a vector quantity, and I am defining a velocity, not a speed. Okay, as I have included direction. Clear?
Yeah, clear.
Okay, so it is a velocity is a vector quantity. Now let's say um, I told you that I have traveled 20 kilometers. Okay, I have traveled 20 kilometers. Do you know where? Did I tell you where?
No, you didn't tell me what.
I didn't tell you where. So basically, I have just give you a magnitude or a value. So that would be what? My distance, right? I have traveled 20 kilometers is my distance, right? I have distance traveled. So that would be a scalar quantity, distance. Okay. Now I
Yeah.
have I tell you that I have traveled 20 kilometers to UK, let's say. Now I have given you a direction, right? Let's say
Yeah.
this is Bangladesh and this is UK. So I have traveled 20 kilometers in this direction, and I have given you a value and the direction too. So this will give me a vector quantity, right?
Yeah.
So the vector quantity of distance is displacement. Clear?
Yeah, that's clear.
Okay. Now let's say are you good with graphs? Do you know like
I'm
how graphs
Yeah,
work?
okay.
Okay. Let's say this is a graph of distance. No, don't write distance here. Oh, wait, let me erase that. Let's say this is time and this is distance. So basically, if I go upwards, the distance increases, and if I go to the right, the time increases. Okay. Let's say here is 5 seconds, here is 10 seconds, and here is 15 seconds, and this is 10 kilometer, and this is 20 kilometer, and this is 30 kilometer. Okay.
Okay.
Now, if I am at this position, can you tell me like what would be my distance estimated this position?
That position will be the time would be around
This
two
would
or
be,
three, and then the distance would be like five,
yeah, the
6.
distance would be like 5 6, yeah, right. So let's say um I was at time equals to 5 seconds, I was at 10 meter per second, 10 kilometer. Okay, my distance traveled was 10, and then at uh 10 seconds my distance was 20, and at 15 seconds my distance was 30. Okay, and I can draw a line through here, right?
Yeah.
So this tells me that I was traveling with a certain time and a certain distance, right?
Yeah.
Now, what was the formula for, let's say, speed?
The formula of speed.
Yeah,
Speed is distance over time.
it was distance over
Time.
time, right? Um, do you know how to find gradient of a graph?
A gradient of graph, yeah.
Yeah, like how? Do you know the rise by run rule?
Yeah.
So basically, if I were to draw this is my rise, right? This is my rise, and this is my run, right?
Yeah.
So how much did I rise? 30 kilometer. Like, let me find the gradient. I did not gradient with m, so let's say my rise my rise by run, and the rise was 30 kilometer, and the run was what, 15 seconds, right? That is huge speed. I have traveled 30 kilometer in 15 seconds. It's scary time. Okay. um did you get this? I have found the gradient, right?
Yeah.
So what's my gradient? Is 2 kilometer per second. 2 kilometer per second, right? And
Yeah.
isn't it the exact same thing? If I were to tell you that find the speed for me, you would use this distance over time formula, and you would put the distance I have traveled is 30, and the time I have traveled is 15, and this will also give me what, 2 kilometer per second, right?
Yeah.
So basically, if I find the gradient of a distance against time graph, I would find the speed. Is it clear?
Yeah.
um sure.
Yeah, I'm sure.
Okay, so let's write this. The gradient, the m of the speed, sorry, not speed, distance against time graph give me what speed? Sorry, yeah. Is it clear now?
Yeah.
Mm, let me fix that. Okay, did you copy these things?
Yeah.
Okay, now let's say, let me change the quantities, and let's not write distance, let's write displacement. We know what displacement is now, right?
Yeah.
That's right. displacement. So could you identify what would be given by the gradient of this displacement time graph? Like what can we find from the displacement time graph?
You can find like the fastest like route possible.
Yeah, like we have found speed from the distance time graph. So if there is a displacement time graph, we can find its velocity by finding the gradient, right? Because
Yeah,
displacement is the vector quantity of distance and velocity would be the vector quantity, because as there was a scalar quantity in the y-axis, we have found the scalar quantity, and as there is a vector quantity in the y-axis, we will be found we can find the let's say the vector quantity of speed, which is velocity, right?
yeah,
So this is velocity, and velocity would give me the exact 30 over 15, which is 2 kilometer per second. That is the velocity we can find. Okay.
yeah.
Wait, sure. Sometimes give me a hard time. Is it clear now? There was displacement, that's why there is velocity, and here it was distance, that's why this gives me speed. Is it clear?
Yeah.
Okay. Now let's say, let me bring the this thing again. And let's say we don't write displacement here anymore, and let's say we write velocity.
Okay.
Can you tell me will what we can find from its gradient? Think of it.
Would then you find the displacement?
No, like let's say what's the gradient of this? Rise by run, right? This is the
Yeah.
rise here, which is
Yeah.
velocity, which is change in
Yeah.
velocity, right? The rise is
Yeah.
change in velocity when the velocity was 0 and then the velocity is 30. Let's say we erase the kilometer here, we don't need that, that was for displacement and distance. So at first we were at 0 meter per second, and then we are at 30 meter per second, right? So this is the
Yeah.
change in velocity, and at here the time was 0, and then in here the time is 15. So this is the change in time, and the time is 15, right? Which is time. So can you tell me what this expression is?
Change in velocity over time.
Yeah. This is the expression for acceleration.
Okay.
Remember from here. Here, where? Here. The change in velocity over time, right?
Yeah.
So the velocity time graph's gradient will give me what? Acceleration. And here the acceleration is also 30 over 15. That gives me 2 meter per second square. Let's say. Clear? Is it clear?
Yeah.
Okay. Now let's say um, we again copy this, and we can find the area under here, right? If we want, we can find the area, right? Here we can find
Yeah.
this area if you want, right? Sure. Right?
Yeah.
Tell me the formula for finding the area of a triangle.
Base hand side divided by two.
What?
Base hand side divided by two.
Base, or let's say half into base times height. Now, we can see that the height is the change in velocity, right? As this is a velocity time graph, so this is the change in velocity from 0 to 30, right?
Yeah.
So the height is basically change in uh, change in velocity, and the base is what? Can you tell me?
The base is 17.
No, what is base like here? It is the
Base is like
time,
the
right?
bottom part. Yeah.
No, 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 no. It is the time from this graph's perspective. This is the time, right?
Yeah.
It is the increase in time. So can you tell me what what is the formula of let's say speed or velocity? Let's say speed. Speed equals to distance over time, right?
Yeah.
So if I were to subject distance, let's subject distance, the time, we multiply time in both sides, and this time cancels out, right?
Yeah.
So we are left with speed into time, right?
Yeah.
um isn't it the same, the velocity into time and the speed into time? If let's say it's not velocity, let's keep it speed, let's keep it simple. Speed, and this is the speed, right? Aren't these two are the exact things? This speed into time and the speed into time. Are you getting me, or is getting
Yeah. Yeah. I
complicated?
understand.
What?
Yeah, I understand.
Okay, so basically, if I were to multiply speed and time, this will give me distance. So, and here this is also speed and time, and I'm multiplying it, so these two will give me distance too, right?
Yeah.
So let's say half, shit, wait, half into uh, speed into time, and this thing will give me what? The distance. Speed into time, this will give me the distance. So half into distance, which is distance over two. Can you tell me the distance here from this graph now?
That's
The height is 30 and the
yeah.
base is 15, so it is half into 30 into
15, which is 15 times 15.
15, which is 15 times 15, and that gives me
225.
225. 225, right? So what can we conclude from this expression? Can you tell me?
We can conclude that if we have like uh, the distance and like time or like velocity and time, you can find
We
you
can
know, you
find
have the
the
speed and time. Yeah, you can find the
distance by
distance. Yeah,
finding the area under the graph, right?
yeah,
So if we have speed against time graph, we can find the distance by calculating area under the graph, right?
Yeah.
Is it clear?
Okay. Yeah, that's clear.
Okay. If it's clear, then let's you have to tell me now that if I just change speed by velocity, how can I what will well, like what can we find by the area under the graph?
You can find that's the time.
What?
That's the time. You find the
Let's say I told you that find the what we can get from this area under the graph.
area under the area under the graph. You can find the distance.
No, it was for speed. We could find distance when there was speed and time. Now there's no speed, there is velocity. It's a vector quantity.
So
So
the
we will,
displacement.
yeah, we will get the displacement, the vector quantity of the distance, right?
Yeah.
Will give me the displacement. Is it clear now? Talha,
Yeah.
is it clear now?
It's clear.
Okay. So basically, let's recap what we have learned. Wait a moment. Yeah. Let's say we have learned that acceleration is what? The change in velocity per unit time, right?
Yeah.
And then what is, let's say, the area under the graph of uh, velocity time graph gives me area under the graph of velocity against time graph gives me what?
The area under the graph gives you displacement.
Displacement. Give me displacement. And the area under the graph of a speed time graph gives me what?
The area it gives distance.
That gives me distance. The area under of speed and time. Speed time graph gives me distance. Okay. What shit, wait. And then we have learned that how can we find the acceleration from a speed time graph, let's say.
Acceleration from speed time graph.
Yeah, how can we
Uh,
find the acceleration for speed time graph? Like how?
Changing that speed over time.
Yeah, like how can we find from the graph?
Yeah, you find you did that the first speed. No, the last speed minus the first speed over the time.
Yeah, like what can we find from the graph? Like what we have to calculate from the graph?
You have to get the first speed, the speed at the beginning.
Yeah,
Then
we
you
know
get the
that.
speed.
No. I was asking that how can we find the acceleration from here? Like let's say we just know this thing. Like how
Okay,
can we find that?
you do 30 minus 0 over 15.
We have to calculate the gradient, right? The gradient here. The gradient gives me what? Acceleration. Remember?
Yeah.
So what? The gradient, the m of speed time graph gives me acceleration, or let's say velocity time graph. Let's not write speed. Velocity. Is it clear?
Yes, clear.
Sure.
Yeah.
Okay, if it's clear, let me give you some exercise to do. Give me a moment. Okay, let's say I have given you this graph of time in hours and displacement in kilometers, and let's say this is okay. Okay. Now I have told you that find the velocity from this graph. How can you find this?
The velocity.
Yeah. Give me the value.
Uh,
Give me the value.
the over time. You do displacement
What?
time displacement times time. I think
Yeah, this is displacement over time,
it
or
will be
displacement time graph.
225.
What?
Would it be 225?
39.5.
225 for the first one.
25. Point what?
225.
225. So
Yeah.
that is the velocity, right? So you
Yeah.
have, what did you do?
I did 15 times 30 divided by 2.
You did 30 times 15 divided by 2. Yeah.
Yeah.
That's not correct. I have told you to find velocity, and turn over your notes and see that what gives me the velocity from a distance time graph.
The displacement.
Displacement time graph. Yeah, what gives me the velocity of a displacement time graph?
It is. Would you would you do that the change in displacement over change in time?
Yeah, I have to do that because that's the gradient, right? I have to find the gradient. What was it? That the gradient of velocity time graph gives me oh wait, where here the displacement time graph's gradient gives me here the gradient of the displacement against time graph would give me the velocity. So I have to find the
Okay,
gradient of this graph, right?
that'll be two.
So that would be 2. So 2 kilometer per hour. You have to mention the unit too. Okay. And do this one then.
The fun.
What?
Oh, the find the acceleration now.
Yeah, I have to find the acceleration and the displacement.
Which off?
For this graph. This is the second part.
Okay, so
This is a
find acceleration,
velocity time graph.
speed equal distance over. Would it be the gradient? So it's gonna be
Yeah, that's the gradient. The acceleration would give me from the gradient. The gradient is what? 30.
30 over 12.
Yeah, this is 30 over 12. And this will give me just a 2.5. Okay,
Okay,
2.5. And what about the displacement?
it would just be the area of the triangle.
Yeah, that would be the area of the triangle. This area, right?
Okay,
So, so what's the displacement value?
what do I find now?
What?
What do I find now?
I didn't get you. What?
What do I find now?
You have to find displacement here. This one.
It's the area of the triangle.
Yeah, find it. What's the value?
30, 15 times 180.
Here it's 180. 180 kilometer. Is it clear now? Because in
Yeah.
exam, you'll be asked to find these things from the graphs, and you have to make sure that you can find it easily. So you at first you have to memorize these things that I have taught you already. Like what gives what, like, as the area under the graph of a velocity time graph gives me displacement, the area under the graph of a speed time graph gives me distance, and the gradient of velocity time graph gives me acceleration. Okay.
Okay.
Okay. So do you have any question?
I don't have any question.
Okay, wait, no. Let's say this is the last one. After, oh sorry, this is the last one. After that, we'll finish with the class. Let's say now, let me copy this one.
Uh,
Let's say
the-
here this is 50 and here this is 70.
this one here.
Okay. Now I have asked you to find the displacement from here. Can you do that?
And the space one here, yeah.
So what will be the
30.
displacement?
It'll be 100, 1,620.
What? 1000?
1,620.
1620. Okay. How did you find it? Let's see. We at first we find how did you find it?
I did 30 times 12 over 2.
30 times 12. Oh, sorry. 30 times 12.
Yeah,
Then over
over 2.
2.
Yeah.
Why is that? Why did you do 30 times 12 over 2? That gives me 180.
Yeah.
And then,
Then
so this gives me the area of
30,
this part, right?
38 times 30.
38 times 30. So that would give me this part's area, right?
Yeah.
Okay. So this gives me 30 times 38, right? This gives me what? The value? Wait a moment. Give me a moment. Wait, I'm coming. Huh, yeah. 30 times 38, right?
Yeah.
This gives me 114. 1140. Okay. And then what did you do? You find this part,
Uh,
right?
yeah, I did.
You found this part, which is, let's say, 20 times 30 over 2. That gives me 30 into 20 over 2. That gives me 300. And then you have added all these values, right? Which is 180 plus 1140 plus 300, and this gives me what? 1140 plus 180 gives me 1620. Well done. Okay. And now we'll be packing up with an exam style question. So let me switch the screen for you.
Okay.
Yeah. Can you see?
Yeah, I can.
Okay. So basically there is a graph here of velocity against time. So constant velocity of the graph is shown. So we have to find the velocity of the graph, right? How do we so what gives me the velocity of this graph? The area under the graph, the horizontal part of the line, or the slope of the line, or the sloping line at the start? So basically, is this line gives me the constant velocity, or the slope at the end? This gives me the constant velocity.
The horizontal what?
Yeah, this is the horizontal line. This is where the velocity is constant, right? The velocity is not changing. Okay, nice. So the answer would be B. Then the distance traveled is shown by, how can we find the distance travel? By the area under the line, right?
Yeah.
Of a velocity time graph. Okay. And then the average speed of a velocity of average velocity of toy car is given by, how can we find the average velocity of this velocity time graph? Of this graph, how
What?
can we find the average velocity?
The average velocity is total uh, distance moved divided by time taken.
Distance divided by time taken, right? The distance moved
Yeah.
divided by time taken. So answer would be B. And you get 3 marks from your exam. This is the actual O levels exam. Okay.
Okay.
Okay. Is this clear now?
Uh, it's clear.
Okay. So we'll be wrapping up now. And is there any question you want to ask?
And I don't really have any other questions.
Okay. Did you get all of it? Like all the part? I will be giving you the recording. So if